Okay, everyone. So in this video, we're going to do a little nomenclature of alkanes and cycloalkanes. There's only 3 rules we need to follow when trying to figure out how to name them. The first rule, and we go in this order, the first rule is to identify the longest chain. This is basically you being able to put your pen down or pencil on the structure and going through it without having to lift up off the page. That's the longest continuous carbon chain. The second thing we want to do is give the lowest numbering possible. Let's say lowest numbering priority. And the third thing is we want to write out the name in alphabetical order. Okay. So let's do some examples to put those rules to the test. So let's say we had something like this. So hopefully you were able to see that the longest hydrocarbon chain, carbons and hydrogens, runs this way. So it's a 3-carbon chain. If it's a 3-carbon chain, you know it's going to be propane. Prop, basically, P-R-O-P. That signifies that you have 3 carbons in a row. And here, so we've done rule number 1. Rule number 2 is to find a numbering sequence that gives us the lowest numbers possible. So here it doesn't really matter if we start from, let's say, the top and make that carbon 1 and make that carbon 2 and make that carbon 3, because the bromine, our functional group, is going to be at 2. Right? If we made that 1, that 2, and that 3, it's still at 2. So we know we have a 2-bromo. So the name of this would be 2-bromo propane. Okay, what if we had something like that? So what's the longest chain here? Well, if we start from, let's say, the left side, we can start from here, here, or here. That would be carbon 1, any of those. This guy is going to be carbon 2, 3, 4, 5. And of course, it would be the same going from right to left. 1, 2, 3, 4, and then we can go in any direction. It would be 5, 5, or 5, right? So this is going to be a 5-carbon chain. So it's going to be a pent. And we're just on alkanes and cycloalkanes, all single bonds, so you know it's going to be pentane. So let's say I make my longest chain this one right here. Well, that means that one of my carbons has 2 methyls sticking off of it, because that's a methyl, right? And that's a methyl. So I can start numbering left to right or right to left. If I go left to right, my 2 methyls are going to be at carbon 2, so I'm going to have to write 2,2 dimethyl. Had I gone from right to left, my carbons would have been at the 4 position, so it would have been 4,4 dimethyl. So what's a better lower numbering sequence? Obviously the 2,2, not the 4,4. So we're going to be naming it from left to right. So the name of this compound would be 2,2-dimethyl pentane. Okay, let's switch it up a bit. What if I had this? So what's the longest chain here? So hopefully you were able to identify that the longest chain is still a pentane, right? So we can say that this is carbon 1 or that, then carbon 2, 3, 4, and 5. If we went in the other direction, wouldn't really matter. Here's carbon 1, there's 2, there's 3, there's 4, and any one of these could be carbon 5. So we know we're dealing with a pentane still. We also know that on one carbon we have 2 methyls sticking off of it. So we're going to have a dimethyl. But then we also have a bromine sticking off of one of the carbons right here. So that's going to be a bromo. So all of these things are going to be in our name. So we were able to identify the longest chain as our sequence of rules. The second rule is to identify the proper numbering sequence. And that really is the most important part about all of this. So if we choose to number this from left to right, the substituent groups that we end up encountering are going to be at the 2,2 position, because there's 2 methyls at 2, and carbon 5 is going to have a bromo. So we would have a 2,2 dimethyl and then a 5 bromo. But if we numbered it from right to left, we would have had a 1 bromo, 4,4 dimethyl. As the naming of our substituent groups. Now, I know you might think that we have 2 4s here and we only have 2 2s there. That might be better going from left to right. But the fact that we have 1 bromo, the fact that we have a 1 here and we don't have a 1 in the blue going from left to right makes the pink numbering from right to left the better numbering sequence. So 1 4 4 beats out 2 2 5. Okay? So the name of this structure would be 1 bromo, 4 4 dimethyl pentane. Let's see what else we can do to it. So what's the longest chain here? So the longest chain obviously is that linear chain in the middle right here. 1, 2, 3, 4, 5, 6. So that's a 6 carbon chain, so you know it's going to be a hexane. And if we start numbering from left to right, let's say, we're going to encounter our first substituent at carbon 3, right? Because this would be 1, 2, 3, and then 4, 5, let's say 4, 5, 6. So we would end up naming it 3-bromo 4-chloro. Had we gone from right to left and said this was carbon 1 and then 2, and then 3, 4, 5, 6. Well, it still would have been a 3, 4, 3 chloro, 4 bromo. So in terms of the numbers, it's 3 to 4, 3 to 4. So the tie break is going to be the alphabet, and bromo, B, beats the C for chloro. So we're going to stick with the left to right sequence. So we're going to call this 3 bromo, 4 chloro, hexane. Okay, now let's do something else. Okay, now let's try something a little different. What if we had this? So hopefully you're able to see that if we start numbering from left, well, the longest chain, right? The longest chain is going to be obviously the only hydrocarbon chain that we have right there, all those carbons. So that's going to be 6 carbons long. So we know that's a hexane. And then we know that if we start numbering from left to right, our numbering sequence is going to be 2, 2, and 4, right? If we start numbering from right to left, we would have been 3, 5, 5, right? So we want to start numbering from the left and go to the right. And so we're going to have 2, 2 dibromo, and we'll have 4 chloro. So now when we write out our structure's name, we have a dilemma. Do we want to write the chloro first because C in the alphabet is before a D, or do we want to write the dibromo first? And the answer to that question is we write the dibromo first because the prefixes here, di and tri and tetra and whatever else, they don't matter in terms of the name. The only thing that matters is the actual atom. Bromo, chloro, fluoro, methyl, ethyl, propyl, things like that. That's what determines the name. So B comes before C. So the way we would write this out is we would say 2,2 dibromo, 4 chloro, hexane. We wouldn't have written the chloro first, like 4 chloro, 2,2 dibromo, etc., thinking that the C of chloro beats the D of di. We never look at the di's and the tris and the whatevers. We look at only the actual name of or the letter of the actual substituent. Okay? So this would be wrong. And the name would be 2,2-dibromo 4-chlorohexane. Okay, now let me give you a kind of crazy looking one. Okay, go ahead and pause the video and let me know, or I mean, I can't hear you, but just try and figure out what the longest chain is in this structure. So I'll give you the answer in just a second, but you can go ahead and pause the video. Okay, so it's kind of hard to see here, but the answer to this question is that the longest chain in this video is going to be if you start from the top or the bottom. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a 9 carbon chain. So it's going to be a nonane. Nonane. If we went in like the left to right direction, we would have gotten, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Not quite. Maybe if we went up, we would have gotten 1, 2, 3, 4, 5, 6, 7, 8. Still only 8. So going up and down that chain turned out to be the longest chain. So it's a nonane. So basically, we want to see where we start numbering. So do we want to start numbering it from the top to the bottom? So 1, 2, 3, 4, 5, 6, 7, 8, 9, or go from the bottom to the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, remember, we found the longest chain, which was rule number 1, right? Rule number 2 was lowest numbering sequence based off of the substituent groups that branch off of the main chain. So the dark blue, going from top to bottom, would give us our first branch at position 4, and that would be this methyl. So I hope you can see that. So if we go from the top to the bottom, our first point of difference, like the first branch, would be the methyl at 4. If we went from the bottom to the top, numbering in light blue, like the sky blue color, our first branch wouldn't be until 5, carbon 5, which would be this part right here. So we want to start numbering from the top down. And if we do that, we realize that at position 4, we have a methyl. And then at position 5, we have a 1, 2, 3 propyl. So the name of this compound would be 4-methyl 5-propyl nonane. Now, what if I had thrown one little curveball at you? I mean, that was a curveball, but like even more of a curveball. So let's say, so same structure. I'm just going to redraw it. By the way, if you got that, you'll get an A on the test. So don't worry, you're not going to get structures that are this crazy. So let's say we had, oh, I messed up. So let's say we had something like that. So the longest chain is still the up and down chain, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's still a nonane, and we still want to start numbering it from the top to the bottom because our first substituent branches off at 4 as opposed to 5. However, the 4 is going to be a propyl. Right here it is. Our 4-propyl is going to be right here. 1, 2, 3. And our 5 position is going to be a methyl. which is this guy right here. So how do we want to write this structure? Remember, our third rule is to write it in alphabetical order. So if we write it in alphabetical order, we see that the M of the methyl comes before the P of the propyl, LMNOP, right? So we write it 5-methyl, 4-propyl, nonane. So even though the 5 came before the 4 when we wrote it out, the actual name, that didn't matter, because when we write out the actual name, we follow the alphabetical order. M comes before P. So let's erase all this. And let's go into, we'll do like a little transition here, go into cis and trans of cyclohexane rings. So let's say we have a ring like that, and we have bromine at that carbon, and then we have chlorine at that carbon. So bromine is equatorial and chlorine is axial, but we know that they're both in the up direction, right? Because the down direction where bromine is this way. There's a hydrogen there. And the down direction where the chlorine is that way. There's hydrogen there. So our substituent groups are both pointing up. The chlorine is axially up and the bromine is equatorially up, but they're both up. So if they're both on the same side, we know they're cis. So the way we would name this is to say it's cis 1-bromo 2-chloro cyclohexane. What if I had that and I did that? So the wedges, the solid block wedge, are coming up above the plane of that ring, of that cyclopentane. And the dashes are going away or going below the plane of the ring. So in this case, our substituent groups, our bromo and chloro, are situated opposite of one another. One is coming up off the plane and one is going down. So one is below the plane, one is in the basement, and the other one is in the attic, right? They're not both in the attic and they're not both in the basement. So because they're opposite in direction, we're going to say that this is trans 1-bromo. There's carbon 1, there's carbon 2, and there's carbon 3. So 3-chloro cyclopentane. Okay, so let's go ahead and erase all this. Okay, and the last thing, let's take a little break from all this naming. The last thing I want to cover in this video is the name of those special groups, the non-IUPAC names, but we still have to know them. So if we have a functional group that has 3 carbons that, so let's say we have our parent chain. I think Professor has called it the main chain. She called it the MC. So let's say we have a parent chain that's a pentane. So 1, 2, 3, 4, 5, okay? And let's say I stick a substituent off of the 3rd carbon. So off of that guy right there. And it's a 3 carbon substituent branch. So it looks like that. So my branch has 1 carbon, 2 carbon, 3 carbons branching off of the C3 of the parent chain or main chain. She calls it the MC, main chain. If I have that, this guy right here is called an isopropyl group. Prop because it's 3. Whenever you see prop, that means 3, right? So the name of this compound would be 3 isopropyl pentane. So I think the kind of short form that Dr. Hess used was just to say MC and something like that. So the MC here is this thing right here. The pentane ring. Made that kind of hairy, but you get the idea. And you have an isopropyl group as a branch off of it. Okay, let's look at a few more, because these I think you do have to know. What if you had, instead of a 3 carbon group, you had a 4 carbon group off of your main chain? Well, if let's say that's your main chain, and you had a 4 carbon group, but it was oriented, let's say this way. How do I want to do this? So we have 4 carbons, right? 1, 2, 3, 4. Because we have 4 carbons off of our main chain, we know it's going to be a bute. So butyl. And this kind of configuration is going to make it an isobutyl. So I'm not going to write MC for main chain. I'm going to draw in a chain. So let's make it into a hexane, okay? So the main chain is right here. I'll make it a little thicker. So off of its 3rd carbon, we have a 4 carbon group that's branching off, and that's called an isobutyl. Okay, so let's say we have that hexane, but we reorient the way the carbons in our butyl are organized, structurally organized. So we're essentially just making a structural isomer. And what if we do this like that? That's 4 carbons too, isn't it? There's 1, there's 2, there's 3, and there's 4. You know what, let's make this into a heptane or even octane, okay? I'll just make it into an octane so there's no doubt what the parent chain is. The longest hydrocarbon chain. So the MC, main chain, is an octane. So off of the 3rd carbon of the 2nd example, we have 4 carbons, a 4 carbon group. So we know we have a bute. So it's a butyl, but it's not organized the way the isobutyl is. It's organized in a slightly different way. This we would call a sec-butyl. And the 3rd one that we have to know and this one is super important. So here's our parent chain. We'll draw an octane. 1, 2, 3, 4, 5, 6, 7, 8. And if the third one has a carbon and it has 3 methyl groups off of it, 3 other carbons, that's still a bute, right? The functional group is still a butyl because there's 4 carbons. 1, 2, 3, 4. But look how they're structured. They're all branching off of 1 carbon. We call that a tert. That's a tert butyl. So let me zoom out. So our main chain was an octane for our 3 examples. The one on the left had the 4 carbon substituent group structured in kind of like a branching pattern like isopropyl, except in this case we had 4 carbons and not 3. So we call that an isobutyl. In the middle example, we have still 4 carbons, so it's a butyl, but they're all in one line. So that's a sec butyl. And in the third example on the right, we still have 4 carbons attached at one spot to the main chain. So that's still a butyl, but they're arranged to be like the 3 of them to be stuck on 1 carbon. So we call that a tert butyl. So make sure you're familiar with those terms right there. The name of this compound, or all of these compounds, would just be isobutyl octane or sec butyl octane or tert butyl octane. And then we can do fancy things to it. If I just put like a chlorine right there, that would be 2-chloro 3 isobutyl octane. And I know you must be wondering, is it the I or the B that comes before the C? Don't quote me on this, but I think it is the I of the isobutyl, the S of the sec butyl, and the T of the tert butyl that determines the alphabetical order when you name it. So the way this is written is correct. And we can just do as many variations as we want. I could have replaced that chlorine with a bromine, and I would have just said 2 bromo 3 isobutyl octane, and on, okay? So let's stop the nomenclature video here, and we'll move on to the next topic.